Hello and welcome to this pre-mortem of the Boolean history pattern, a pattern that I think that I invented. I don't know if it's existing, but it's really cool. This video is a pre-mortem video. It means that I'm doing a documentation archived way that is explaining something like I die tonight. So don't be, it's a disclaimer to know to just say I'm not dying, it's just I'm doing like it to have better documentation. So let's enter the subject of the Boolean history pattern. So what is the Boolean history pattern? It's kind of simple. So if you look at the screen here, I will press play. It's basically considering that the world is Booleanable, everything is Booleanable, 1 or 0, and it's easier in most of the time to code with something that is true or false, that's dealing with plenty of floating, integer, Boolean, a lot of different variables. So what I do is that convert everything that I can in my program in a Boolean, and this Boolean, I have done plenty of tools that allow me to track them through time and to make logic between them, and that's amazingly good. That's amazingly good. I invite you to go in the description to have the code of it if you want to improve it. Look how I did and stuff like this. As I'm dying tonight, effectively, I cannot say I will improve it. It's buggy. It's not finished, but most of the logic is already in it, and there is some examples, some testing around, and yeah, I'm kind of proud of the Open Macro Input project, and yeah, I'll go directly to the subject. So here you can see on the screen that when I'm pressing the space key, I have here the Boolean that come true and the Boolean that come false. The small line here is to say it's just a tracking that allow me to know when it starts recording. So it's here to 2 seconds. So basically here you can see that I have a memory of 300 switches. So basically what happened if we look at the code is that I'm recording what I call a Boolean state period, and a period is just the switching value. So is it switching true or switching false? And the ellipse time, it means the time before that is front of this switch. So if it's in the history, it's the time between two switch, and if it's the first one, it's the time currently going on before the next switch. Okay, and those Boolean state period, as you can see, I just have a list here of Boolean period and the maximum number of it, and all the code around are just some code that to facilitate the lecture of all this information that you can use and deduct of it. There is a third class that is really important, is this one that I coded today, that is called relative chunkable bool history. And basically what it does is that just you take a Boolean history and you say I want to cut from that part to that part compared to now, and I want to ask plenty of questions, so it's a utility on this truncated version of the Boolean history. And so as you can see, you can just ask question, is it empty? So is there some switch? Is there an array of switch to be able to know which one was occurring? Was it switch and still true? So does it go from false to true, and is it still true? So plenty of stuff like this. To give you a bit of an example here, here we can ask the state at 200 milliseconds. So if I press this at 200 milliseconds, boom, it becomes true. And if I release, it will become false after 2 seconds. And so as you can see here, you have a graph that is representing this state, and it takes almost no place because it's just recording the switch and a long to be able to know the time pass between both of them. So here, if I say I want to record just the 10 last switch, as you can see, it will record only the 10 last switch. And if I say I want 30 of them, it's you to decide how many switch you want to record in the memory size. Don't forget that more you have Boolean, more you record in the time, more you take memory place on the computer. It's not a lot compared to what we use in video game, but if you are really, if you like to not lose too much memory size, then maybe you should play with that. So here you can see that I'm tracking at this time the value of this graph, but you can also ask plenty of other questions. For example, you say from 2 seconds to 5 seconds. So here it's the truncate version of the Boolean history. And you can ask question like, does the user maintain true through all this time? So if I maintain the fact to press, you can see that for the moment it's false. And now it's true. Why it's true is because in this truncate version of 2 seconds to 5 seconds, we detect that here it is totally true. So if I release 2 seconds after, because I'm tracking from 3 seconds to 2 seconds to 5 seconds, now it's false. And as I released for a long time, now it means that between 2 and 5 seconds, the user is releasing, so there is no switch, and it's false here. So that's really, really useful. Another stuff that is really useful is the ability to say between this time and this time, what is the percentage of true or false of the value. So for example, here you can see, hop, when it goes from 2 seconds to 5 seconds, as I'm pressing, it's going to the true, to 100% true. But if I switch like tech, you will see that we will have 50% true. Why it's not? Oh yeah, I will do it more gently. So here I'm pressing continuously from true to false. And you can see that basically here it will switch to 50% true based on what I'm doing. Here it will go the nearest of that. Yeah, so it depends on if I'm pressing a lot, if I'm not pressing a lot, extra. I should not say extra because in English it's bad. But yeah, so yeah, that's the a very good part. Another part that is really cool is the ability to track a bump or a hole. So for example, here we look at a bump true. A bump is when it's doing this. So you can see here that I'm bumping on the false curve to true. And so here you see a bump to true when it will go here and bump true. Okay? And a hole is when you are pressing false for a long time. So I'm pressing false for a long time. I will do a bump, but in the other way. So a hole in the platform through, like this, you can see. And here you can see that we have a hole in those periods. So you can have information about the duration of the hole and how many holes you have in the timeline. I did not code the part that can allow you to have more information about the hole, like at what precise time and stuff like this. But if you want to code it, it's quite easily. So look at my code and add what you want based on the code. But yeah, basically it's almost all what you can do. If you have idea, you can implement other idea. But basically that's all you can do. Why it's very, very cool? Because here it looks like quite of just an experiment in Unity, but when it's become cool, it's when you do this. So that's the other part of the utility. So there is a Boolean history, that is what I show you. But if you do a Boolean history of plenty of Boolean that you name, you can have something that I call a register Boolean, where you keep the track of those timeline based on a name of a Boolean. And here is an example. Now what I can do is that I can write something like this. If, and then I say the user is pressing up and is not pressing down, but but shift is there, exists and is used, is false. True for 50 milliseconds. So, for example, here, what I write, it's the Boolean logic. Could you check if in the register that is the default one of the application, you can create some logic for a specific register, but here I just say, could you take the default one that is set over there? Could you check if the user has the arrow up true, the arrow down false, so he is moving forward, that the shift key has been used, and if it has been used, could you check if the shift is pressed? Is pressed for 50 milliseconds. Is maintained for 50 milliseconds. So that's the kind of logic that you can do. And here the T and E mean true or not, no error, true and no error. It means if the equation is true and if everything was alright to compute, because there is plenty of situation that can trigger something that will fail the computation, and so you need to be able to know that. I invite you to go see the code if you want to understand a bit how it's working, the BL and if, and those parts, because that's not the main topic of the video. So what is that? Because you know what is a regex, you know what is programming, but what is this language? This language is a topic of the what I was coding. Is that basically you can write a lot of logic based on the Boolean history that is in a register, and it look like this. So basically here I have implemented in the current code. You can check the code and look a bit how it's working. It's not finished, and so I invite you to finish it for me as I'm dying tonight in the context of this video. But basically what you can do with this code is the ability to say if those Boolean are true, all true, is all of them are true, or one of them are true. So here it's an and or for people who know computer. This video is for people who know how to program, so I suppose that you know what is an and or. Here we have the XOR. XOR, it means if one of them is true and not one of them must be true, and at least one of them is true. Okay, at least one of them is true, but only one of them. The and, not and, the not or, it's the same as and, but the inverse. So you can write it like this, but you can also write it with the Unicode that you want. So that's a XOR, that's an and, that's a or, that's equivalence. So equivalence, it's equal. So it means does the Boolean are all true or all false, but not different, for example. And here it's a domino operation. So a domino operation is all those variables are false and all those variables are true. And so you use the direction of the domino to be able to determine that, to say that. So here is if the user is pressing up and down and not pressing left and right, for example. And that's super useful when you do a video game to be able to know what the user is doing. And instead of writing is that it's true, is that it's false, is that you can just write this. So you can say, yeah, but I can use it with a classic way of doing it. Yeah, you can use it. But don't forget that in this situation, you can also write something like this. Is up is true, but is up was not true. Not true is this. For there is not true is this one between 0 and 60. Okay, so here, for example, I'm saying is up is true actually, and is up was not true. There is 50 seconds to 60 seconds. I will say to 6 seconds. So, for example, the last 6 seconds, I hope that up was not true. But for the moment it's true, and I consider that left and right must be down at the moment if it's considered to be true. So you can see that it's really useful to be able to write some conditions that are reflecting through time. And so here are more some logical classic one, but here you can see that those one are those that allow you to track with the history Boolean. So for example here I'm saying is shift has been released, has been pressed for 200 milliseconds. Is it being released for 200 milliseconds? The arrow allow you to say is any switch through the false or the Boolean state true has been occur to the last 200 milliseconds. Okay, so that's really useful to be able to make some logic, like because you can do logic like this. So for example, is left or right is true, and up is up, and down plus up is true. So you can really do some classic Boolean logic, but with time value here. So here is some example of Boolean logic that my code allow you to do. So to allow a bit every developer to use what he like, I also in this version allow to say or like this, or like this, or like this. So you can choose whatever you want. And there is also the inverse or the inverse, and here it's some other symbol that you can use. So there is two type of operation. There is the Boolean operation, the duo Boolean operation that allow you to do one Boolean with one other Boolean, and the group operation where that allow you to have plenty of Boolean in only one group. So yeah, here come back to the stuff. Here you can see that if I say is this situation is true, and there you put the millisecond that you want, and if you want to talk in second, you just say s or m second or minute, and if instead of saying is it this condition at this time, you can also between this time, and that's what's happening here. So here I'm saying is shift was maintained as true between 200 milliseconds and 400 milliseconds, for example. And but you can also use the time of the day. So in some situation, you want to be able to track the time of the day. For example, you are playing a game, and you just want to say between 2 o'clock and 3 o'clock, I would be to know if the user is using shift, and is it true I do something. So for example, you could say, if you use for smart house, you could say if between 2 o'clock and 3 o'clock the heat is on, then you could disable it. Yeah? So here I'm just checking if a switch happened to this time, and if the switch happened to this time, it means that the heat is on or not on. Here it's not on, because not on is down and on is up. And so you can, yeah, basically it's a very easy way to check Boolean through time. And how you write that, it's hours of the day, then minute, then second, then millisecond. And if you want to use more more easy to understand, you can also write it like this, with 12 hour, 45 second, 30 second. Don't put space, because what I have done in my grammar is that if it starts by alphanumeric version here, and it's followed by those signs, those one, one of those signs, it means that is a Boolean in the register, and if you put a space, it splits the information. So a Boolean checked through time must never have a space in it. That's why it's compressed on one another. It's what allows me to make the differentiation between an item, so a Boolean value in time, compared to an operation that the user wants to do. So yeah, this one, for example, it's you remember that I was talking about the bumper here. So for example, if you want to track is the user click 2 times in a row, so here like this, up, you can see that here I have 2 bumper. It means hop, hop, and it's already too late, I think, because it's missing something. Yeah, no, it's okay. And here you can see, okay, I have two bumper that is true here. And so here when you have shift bumper 2, it means in the last second, do the user did 2 bumper. And what happened is here is that you can say 2 bumper plus mean 2 bumper and more, or more, and less it means 2 bumper or less. Okay, so you can say does the user at least click 2 times or maximum click 3 times, for example. If it's for example, if you are checking the user of, if you want to make an application that restarts every time the game you are playing, but if the user life, if the user lose life, for example, you play Doom and you want to restart the game each time the user takes some hits. You could take the life of the player, track them with the pixel of the screen, and say here, if I detect that the life is moving more than 3 times in 1 hour, then we start the game. For example, to give you a bit of example of how to code in 1 sentence something cool. Here percentage is kind of cool too. It's does shift was at least 80% true during 0 and 1 second. And how you can use this percentage stuff is because sometimes you're pressing a button, but you can easily release it and repress it because you are on pressure and you have some stress and you're like and that's finished. So you can use it just to counter those situations, saying is it almost true during this time, but you can also use it to be able to check stuff like this. For example, here I'm saying if the user is pressing the mouse left and he do two bumper with the mouse right, then we are in the situation when we want to do something. And base, if I'm using shift or I'm not using shift, then I will do something or something else, you see? So here is an example of how you can do it. So basically you select something and you click tac 2 times with the right one and it will do an action. And you can change it by putting 3, 4, 5, 6 or something like that, and you will have different behavior based on the number of the time you right click while using the mouse left click. And if that is not amazing, I don't know what it is, because man, I'm loving this kind of logic, because when you are doing some contextual macro or some yeah, it's really sad because I know that it's amazing, but almost nobody know about it. But yeah, okay, that was another example to give you a bit of taste of the stuff. Is here I'm saying if the mouse right is pressed at 70% of the time during the last 2 seconds. So it means that it must be pressed, but not all the time. Okay, then it means that it's true. And here you make one that is checking that and that's saying the user is asking something for the moment, and you do another command that is mouse right is the mouse right pressed? Mouse right, yeah, left. Is the mouse left pressed? And no, okay, what I'm saying is just sorry. Just because I tried to make an example to show, but I did not try it yet. So here I'm saying it must be almost all the time on, but when it's not on, you can create some holes. You remember the holes? So a hole is when you're doing something like this. So you are pressing something, and then you release and you repress. And see here you have a hold. And so what happens is that here I'm pressing, and I'm creating two holes, and it means do an action, because for example, the action could be I have this object in the hand, so when I'm pressing, it's following my hand, and when I do one hole, it turns the controller like this. And if I do two holes, so I'm holding the stuff and I do this, so two holes, it will do this. And so it's really cool, because when you are coding a game or an application, you just need to write that small line of code, and you have something that allows you to put some code behind those logic and to have a game that is really doing actions through time and through context. And yeah, what do you want me to say except that I'm very proud of what I'm coding for the moment. And I was really exciting to use it. So the logic behind it, if we can see some example here, is that you have a part that is a textual part that is converted to class, and those class, I call them the logic block. So for example here, when I'm converting it, I'm creating it will become a bit complicated if I explain all that. I prefer that you look at it. But basically what happened is that I've created a logic builder. So here, builder. And the logic builder allows you to say, I want to do an operation here, happen let. Here, apparently it's an operation of two Boolean, that is an end condition. So in the end condition, I want to use the current one and add to this end, at the left part of the equation, if the up key is down. And for example, that's how I create logic. You could say, is the up exist? Exist, it means, is it in the database of the object that I'm tracking? Because for example, if you are not tracking the up key, then it will put an error. And so here you can say, is it at least existing before I try to compute it? Here is just to check if it's true or false. Here it's to check if it's true or false at some time. So you have plenty of Boolean logic that will deal with a little bit of logic, and that you can merge together to have a big operation. You can do it like this in code in C# if you want, or you can do it like this in text if you want me to parse it. So when you're doing that, it's just you trusting me to parse what is here to those Boolean logic. And when you are doing this part, what happens is that you have no, that's not the good one. You have the same situation, but with yeah, it starts to be heavy, huh? With those stuff, logic Boolean. Oh yeah. So basically, the good stuff to know is that I have split the work in different parts. I have the logic part here, as you can see, that is working without the register, without the time Boolean, so it's just Boolean logic. And I have the Boolean history and the Boolean register that is another part of the program that is working independently. And behind that, I have the parser. So here, for example, it's some basic logic class that all inherit of logic block that you can use together, that you can mix together. And if you want more detailed version, you can implement your own one and add it to the logic builder. So it's what I have done here. So as you can see, I'm trying to find an example. For example here, is it a good example? Boolean time key? No, it's not a good example. Yeah, sorry, it's a bit far in my head. Yeah, this one. So for example, here, if we look at the code, we will go up. I have Boolean logic, and the Boolean logic must answer the question whatever inherit from this, what is the Boolean value that is computed if I ask you to compute it, and is it computable? Because if an error happens, I want to be able to warn the user that I did not compute correctly. So did it compute, and is the value true? Okay, and the stuff is that if you have this abstract version of it, you have some block of logic that don't need time, but you have some block of logic that need time. For example, when you are asking if the value is true at this time, you want that every logic use the same exact millisecond time. And so what you do is that you say, is it true? Is it computable? And you send the time to say, if you need to use the time, use this one. Okay? And so now that we have implemented the time value, we say, okay, so I want to be able to track a Boolean that is not a primitive one or default one that you can use on the top of here, but I want a Boolean that is in the register of my application. And so what you do here is you say, okay, I have this register that I gave you, okay, and I want you to compute if compute set register is Boolean register exists. Before computing, I want to check if the Boolean exists and the register exists, because if the Boolean don't exist, no need to compute. If the register don't exist, no need to compute. There will be an error. So I'm just saying, is the register exist and the name exists? If yes, then the logic need to be computed below. And here we are in the below, and the below here it's, could you in the register reference check the state at this moment? And it's a block of logic, so consider it as a block. So here I stored a version that is independent of the code, that is Boolean item true or false at. If we look at what it is, it's just something that stores what state we are observing, okay? And if you go here, it gives you the time where you want of what you want to check. So here I storing the time, and you will say, yeah, but why it's not a millisecond? It's because basically the logic will change a lot if you ask no time, if you ask at one part of the timer, or a large part of the timer, and is it compared to now or compared to the time in its globality. And so all that is stored in this variable. It's a way for me to have maybe it's bad code, I don't know, but it's working well. Yeah, it's working for the moment. I'm not sure it's a good way, but it's working. So I stored the time in it. So here we go back to our stack block. So now that I know what I want to track, the time I want to track, and I know that it's a logic, I just here say, okay, if someone asks me to compute if the value is true and did it compute, if he give me the time, I use the time he wants, and if he don't give me the time, I use my time of now. And so what I do here is just checking, okay, is it existing? Yeah, okay. does we have a history Boolean? So it's what I show you earlier, the graph with the 1 and the 0. Okay. Yeah, he has a Boolean. Okay, we can continue. Okay, if he has a Boolean, does he has an observer? And does the observer of time is a moment in time or a range in time? So you can see here, key, it means a moment, and range, it means a range. So if it's a moment in time, I'm just asking to get the time that I'm tracking. Okay. So here I will store time in t. Here. In the real time, I mean, that is when we are, and that's the time we are tracking compared to when. Because, yeah. And so here we say, okay, now that I know the exact time I want to track, could you give me the state of this time? Okay. And say me if you compute it correctly, the value. If yes, then I can say to the user, okay, I computed the value, and that is this value. And as we are checking not just if it's true or if it's true, we are checking if it's true or false. I compare that to, is the user is requesting true or requesting false here. And so that is if I check the time, but if I checking a part of the time, then what I need to do is saying, okay, from where to where in time value, and not asking the state, but is was the in the Boolean history was it true? So you can see that the code here is a bit more complex, but it's quite simple. It's just you create a Boolean logic, you store what the user wants from the text parser, and you code the logic of how to connect it to your code. So you will say, yeah, but it's good that it's working, but if I want to code my own Boolean based on my game, do I need to use your Boolean register or not? And that part, my friend, where it's fun, is that if you look here, you have somewhere function or delegate Boolean. Delegate Boolean logic block. So if you want to connect your game to this logic without having to know all this Boolean history logic and stuff, and create something complex, you just create a delegate Boolean logic here, and you give it the computed Boolean delegate. That's a delegate in C#. It's saying this format of function that here I'm saying it don't return anything, but at least I must be able to initialize the value and the compute value. So give me something that is corresponding to that as a function. Okay, you give me that in the constructor, and basically now you can add it to the whole system I have coded about the AND, the OR, the XOR, and stuff like this. And so here, for example, I implemented that for checking if the website is connected. So if a website is connected, I can add that to the logic. For example, if you want to code your stuff, it's going a bit complex. I finish on that, but for example, if for you it's important to check yeah, no, it's not a good idea to talk about that. So yeah, a bit complex everything, but it was important for me to talk about it, to show you a bit where I am, what I have done about this amazing stuff. You have to understand that first, the code is not finished, so you should implement it to your taste, and also that it's very, very powerful, but you need to understand a bit how it's working. And it make part of something else, and it don't replace something else. It is not because I transform everything in Boolean and in logic of Boolean that I'm not using anymore the float, the quaternion, the texture. It's just that it's a tool that allow you to avoid using them when you can, and to easily facilitate your life when you have situation like tracking through time. because when you are coding, most of the time you create some class that will track does the user click through time, and it's really really complex because you need to check the delta time, when it's coming, when it's arriving, when it's going from true to false. And here you have a toolbox that just allow you to say poof poof poof, it's done. And that's the usefulness of this tool. In hope that all this code help you, I say goodbye, good night, goodbye effectively, because I'm dying technically, effectively. And may the code be with you. I hope that my code is not too ugly, and have a nice day. Bye.